Another day, another story. Chandrayaan 3 is on its journey to the Moon. Chandrayaan 3 is a follow-on mission to Chandrayaan 2 to demonstrate end-to-end capability in safe landing and roving on the lunar surface. It consists of lander and rover configuration. It will be launched by LVM-3 from SDSC Shar, Sriharikota. The propulsion module will carry the lander and rover configuration till 100 km lunar orbit. The propulsion module has spectropolarimetry of habitable planet Earth, shape, payload to study the spectral and polarimetric measurements of Earth from the lunar orbit. Lander payloads. Chandra's surface thermophysical experiment, CHASTE, to measure the thermal conductivity and temperature. Instrument for lunar seismic activity, ILSA, for measuring the seismicity around the landing site. Langmuir probe, LP, to estimate the plasma density and its variations. A passive laser retroreflector array from NASA is accommodated for lunar laser ranging studies. Rover payloads. Alpha particle X-ray spectrometer, APXS, and laser-induced breakdown spectroscope, LIBS, for deriving the elemental composition in the vicinity of landing site. Chandrayaan 3 consists of an indigenous lander module, LM, propulsion module, PM, and a rover with an objective of developing and demonstrating new technologies required for interplanetary missions. The lander will have the capability to soft land at a specified lunar site and deploy the rover, which will carry out in situ chemical analysis of the lunar surface during the course of its mobility. The lander and the rover have scientific payloads to carry out experiments on the lunar surface. The main function of PM is to carry the LM from launch vehicle injection till final lunar 100 km circular polar orbit and separate the LM from PM. Apart from this, the propulsion module also has one scientific payload as a value addition, which will be operated post-separation of lander module. The launcher identified for Chandrayaan 3 as LVM-3M4, which will place the integrated module in an elliptic parking orbit, EPO, of size approximately 170 by 36,500 km. To demonstrate safe and soft landing on lunar surface. To demonstrate rover roving on the Moon and to achieve the mission objectives, several advanced technologies are present in lander, such as altimeters, laser and RF-based altimeters, velocimeters, laser Doppler velocimeter and lander horizontal velocity camera, inertial measurement, laser gyro-based inertial referencing and accelerometer package. Propulsion system. 800N throttleable liquid engines, 58N attitude thrusters and throttleable engine control electronics. Navigation, guidance and control, NGC, powered descent trajectory design and associate software elements. Hazard detection and avoidance. Lander hazard detection and avoidance camera and processing algorithm. Landing leg mechanism. Integrated cold test for the demonstration of integrated sensors and navigation performance test using helicopter as test platform. Integrated hot test, for the demonstration of closed-loop performance test with sensors, actuators and NGC using tower crane as test platform. Lander leg mechanism performance test on a lunar simulant testbed simulating different touchdown conditions. The overall specifications for Chandrayaan 3 is provided below. SL No parameter specifications. Mission life, lander and rover. 1 lunar day, approximately 14 Earth days. Landing site, prime. 4 km by 2.4 km 69.367621 s. 32.348126 e. Radio anatomy of moon-bound hypersensitive ionosphere and atmosphere, Rhomba. Chandra's surface thermophysical experiment, CHASTE. Instrument for lunar seismic activity, ILSA. Laser retroreflector array, LRA, rover. Alpha particle X-ray spectrometer, APXS. Laser-induced breakdown spectroscope, LIBS, propulsion module. Spectropolarimetry of habitable planet Earth, shape. 2-module configuration. Propulsion module, carries lander from launch injection to lunar orbit. Lander module, rover is accommodated inside the lander. Propulsion module. 2,148 kg. Total. 3,900 kg. Rover. 50 W. Propulsion module. Communicates with IDSN. Lander module. Communicates with IDSN and rover. Chandrayaan 2 orbiter is also planned for contingency link. Rover. Communicates only with lander. Laser Inertial Referencing and Accelerometer Package, LIRAP. LHDAC, Lander Hazard Detection and Avoidance Camera. Laser Altimeter, LASA. Laser Doppler Velocimeter, LDV. Lander Horizontal Velocity Camera, LHVC. Microstar Sensor. Reaction wheels 4 nose, 10 nms and 0.1 Nm. Of 800 N throttleable engines and 8 numbers. Of 58 N, throttleable engine control electronics. X-band antenna. The objectives of scientific payloads planned on Chandrayaan-3 lander module and rover are provided below. Radio anatomy of moon-bound hypersensitive ionosphere and atmosphere, ROMBA. To measure the near-surface plasma, ions and electrons, density and its changes with time. Chandra's Surface Thermophysical Experiment, CHASTE. Laser Retroreflector Array, LRA. It is a passive experiment to understand the dynamics of Moon system. No rover payloads objectives. Laser-Induced Breakdown Spectroscope, LIBS. Spectropolarimetry of habitable planet Earth, SHAPE. Future discoveries of smaller planets in reflected light would allow us to probe into variety of exoplanets which would qualify for habitability, or for presence of life. Chandrayaan-3 Integrated Module. Chandrayaan-3 Propulsion Module Views. Chandrayaan-3 Rover.